Yeah, this is just a quick screen capture of an interview with Maurice Cotteral, who is the author of a paper called How Gravity Works. Cern, the Large Hadron Collider in Switzerland, is announcing today apparently getting close to discovering the Higgs Bosun, and Maurice Cotteral has an alternative theory for gravity, which doesn't get a lot of airtime or play or whatever, so I thought it would be interesting just to put into the debate the other side of this question. Now, if I can just do this here. This is a thing on Red Ice Radio. You can see on my screen here it's an interview with Maurice Cotteral, Cycles of the Sun. This is 2012 book. What's happened there? My plugin's just crashed, is it? No, there we go. In the lead up to this, this section about Cern, Maurice talks about all the different particles that have been discovered to solve various problems with the unified theory, etc., over the last sort of 80 years, and this is what he has to say about Cern.
Gluons, every time they get a problem, they shove it to one side and marginalize it and move on, and then dust themselves down, give them a few awards and Nobel Prizes, and move on to something else they don't know anything about.
That's right. What do you make of Cern, then, the particle accelerator, the world's most expensive science experiments, when the Europeans, many of the European countries, their economy is totally going down the drain. We're spending billions of euros on this particle accelerator, a big spin cycle. Is it all a waste to look for this Higgs boson particle or God particle, Maurice?
A complete waste of time. Absolute waste of money, waste of time, waste of space. There are two particles, electrons and protons. The neutron, we know from the 1960s, experiments of the 1960s, is made up of a half of an electron glued to half of a proton. And in fact, it's not even glued. They're fused together like a junction diode. And what happens is when you fuse a junction diode together in electronics, you put two materials together, a negative type material, which we call N-type, and a positive type material, which we call P-type, and we fuse them together. And when you fuse them, in between the two, you get a junction, which is on the one side positive and on the other side negative. Now, the junction only exists because we fuse them together. And the same thing happens with a neutron. A neutron, when we fuse together, a half of one electron with a half of a proton, we get a boundary between the two, which particle physics have called an antineutrino. Now, what we know about the antineutrino is if we smash them apart, as they did in the particle accelerators in the 1960s, they smashed two neutrons together like boiled eggs, and they finished up with two negative particles, two positive particles, and two neutral particles, which they called the antineutrino. Now, I'm saying the antineutrino doesn't exist. It's a corridor of fusion. What they find is that the antineutrino disappears, completely disappears, 12 minutes after the experiment. So if you smash two neutrons together, you finish up with two negatives, two positives, two neutral charges, which disappears completely. It just vaporizes after 12 minutes. Well, if it disappears, it never existed. And the reason it never existed is because it's not a particle, it's a corridor of fusion. So that allows us to simplify things. If we've only got an electron and a proton, and a neutron is actually a combination of one half of each, then we can put the atom back together slightly differently to how Rutherford did it in the 1920s. Now, Rutherford described the atom as billiard ball style protons, negative like the negative sign in notation. He looked at his electrons as little negative signs, and the protons once Chadwick discovered them in 1935, he put them as another billiard ball inside the nucleus of a different color. Now, that's why they couldn't figure out how gravity worked. What I've done is I said, look, these neutrons aren't spheres. They're not circular. They're actually spike-shaped. You've got an electron at one end, half of an electron at one end, half of a proton at the other end, fused together with this so-called corridor of antineutrino in the middle, and it's a spike-shaped. And this isn't fanciful thinking. Science Daily, the web-based science magazine, reported in 2008, about March, as recently as 3 years ago, that researchers at the Hahn-Meitner Institute in Berlin have discovered that neutrons behave like compass needles. And what that means is that they align themselves like in line with magnetic fields. So that what they're saying is they've discovered in 2008 that they're spike-shaped. Now, in 2007, when I came up with my theory on gravity, I said the neutron must be spike-shaped because this is what makes the atom stable. So the atom, in my model, looks like a chestnut shell with spikes. So it's spherical, and it's got spikes. Now, the bit in the middle, the protons, are the round bit. Then we've got the spikes, which are the neutrons sticking out of the shell, and they've got negative tips on the edges of each spike. And the electrons can't get to the nucleus because they're repelled by the negative spikes on each of the neutrons. And that's what makes the atom stable. The neutrons behave like springs. They force the protons together and they force the electrons out, and the electrons push on the spiked neutrons, keeping the whole atom stable. And that's why the atom's stable. And once we've stabilized the atom, now we can have a look at what we would need to get energy to interact with that atom, the shape of that atom, to allow us to come up with a mechanism to explain gravity. And that's what future science does. At the beginning, I mean, there's a lot in the book. It's only the first 100 pages or so that's involved with gravity and sunspot cycles and astrology and magnetism, electricity and stuff like that.
Absolutely. I mean, and again, as you mentioned, Maurice, the book is beautifully illustrated, and it's a necessity.
throw that